let's talk about the question 19 in chapter 7. So in question 19, it's talking about the apparatus, okay, to compare the concentration of carbon dioxide in the inhaled and exhaled air. Although it is only a setup, but not the human body, but we still need to recall the concept of two golden rules because we need to deal with the pressure difference and determine the airflow direction. Okay, so you can see that I have two arrows here. One is breathing in and the other one is breathing out, okay, with the mouthpiece. So that means at this time we do not breathe in and out with our nasal cavity, but with our mouth cavity. Okay, so the point is that when we breathe in, okay, to the mouthpieces, okay, so there will be a lower air pressure, okay, in the mouthpiece. And the point is that, remember the golden rule, okay, the airflow, okay, from higher pressure, okay, to the lower pressure, okay, so the air, okay, will flow from this tube, okay, and to the mouthpiece and to your mouth cavity. And when you breathe out, okay, the mouth piece, okay, the mouthpiece here, okay, there will be a higher air pressure because you are blowing air, okay, to the mouthpiece, okay, a higher pressure here, and then the air will flow to the lower pressure region, okay, so along this tube, okay, flow through the lower pressure region, okay. So in this setup, you need to know that what is the airflow direction, and also, okay, how can we compare the concentration of carbon dioxide. So for this page, okay, in this setup, okay, I want you to focus on the right hand side first, okay, and there are two tubes. One tube is in the water and the other tube is in the air, okay. So the point is that this ending of the tube, okay, is immersed in the water, okay. So no matter the fast is fast B or fast A, once the tube is immersed in the water, the tube is immersed in the water, okay. So the airflow must be going down to the water, okay, along this tube. And when the tube, okay, is in the air, okay, so the air will flow through this tube, okay. So that's why in this case, okay, the airflow will flow from this part, okay, and then go into your mouth cavity. And when you breathe out, the air will go through this tube to along this tube to go down to the water, okay. You may think that, how about if we breathe in, okay, we breathe in along this tube? Is it possible? Probably it's impossible. It's not possible because it's just like you put a straw into the water, okay, and then you suck, okay, and then you suck through the straw. So probably you are drinking the water, right? Okay, the straw putting into the water, okay, and then you suck, okay, the water will go along the tube and go to your mouth, okay. So probably in this case, breathe out, okay, air into the water, okay, and this way air out of the out of this region, okay, to go into the tube and then go into your mouthpiece, okay. So in this case, for this tube to the water, okay, to the indicator, so that means the atmosphere, the air in the atmosphere will go to this tube, okay, and then go to the liquid, and the air will go from this tube to your mouth, and the air, when you breathe out, the air will go through this tube to go to the indicator, and then the air will go through this tube to go back to the atmosphere, okay. So the direction you must be able to point out, okay. So we go back to the question, through which fast, okay, would the inhaled air pass, okay, and then give a reason. The reason, okay, probably is that trick, okay. This trick is that, how is the tube connecting? The tube connecting to the mouthpiece is in the water or in the air. That means in the liquid or in the air, okay. So it determines the airflow, okay. So 2 marks, one marks for the fast, okay, and the other marks for the reason, okay. The tube containing to the mouthpieces is in where, okay. And part B, okay, so you can see that you need to suggest a suitable indicator for the for comparing the carbon dioxide concentration in inhaled and exhaled gas, okay. So state the name of the indicator for CO2. So when you were in Form 1 or Form 2, you may have ever studied the lime water or sodium hydrogen carbonate indicator. Okay, and let me remind you, okay, how can they work. Lime water is used to detect the carbon dioxide, okay, and when there is no carbon dioxide, okay, it remains clear, and when there is carbon dioxide, okay, it will turn to milky white, okay, so from clear to milky white, okay. And the other indicator is that sodium hydrogen carbonate indicator. It is used to test the concentration of carbon dioxide, okay. It's not talking about present or absent of carbon dioxide. It's talking about how high or how low of the carbon dioxide concentration, okay. So normally, okay, the carbon dioxide concentration is 0.03%, okay, and then the color of the indicator is red. And if the carbon dioxide concentration is higher than the 0.03%, okay, the indicator will turn to yellow, from red to yellow, okay. And if the carbon dioxide concentration is lower than 0.03%, it will turn from yellow. It will turn from red to purple, okay, red to purple, okay. So in this case, in part B, you need to state, okay, either one of the indicator. Either one is also correct, okay, either one, but not both. Either one is okay. And then for part B2, okay, describe the changes you would expect in each fast, okay, during the 2-minute period. So the point is that there are 2 fasts, so there should be 2 answers and 2 marks, okay. So remember that fast A and fast B, remember to use the same indicator. Some students may ask, can I use lime water in fast A and then use sodium hydrogen carbonate indicator in fast B? Probably, because it is in the same setup, okay, you need to maintain it as a fair test, okay. So use the same indicator for both fasts, okay. And then for part C, okay, this part is quite easy because you need to explain why the air exhaled from the lungs differ in composition from inhaled air. So the point is that the difference, okay, in composition, okay, probably the question did not mention it, so you are the one to mention the difference and then explain the difference, okay. So in this case, what I'm going to tell you is that you need to recall the concept of respiration. Which gas is consumed and which gas is produced, and then you can explain why the air exhaled from the lungs differ in composition from the inhaled air, okay. And the hints, probably you know that it should be oxygen and carbon dioxide, okay. So which gas is consumed and which gas is produced during respiration. And for part 2, okay, other than changes in percentage composition, give 2 ways that the exhaled air differs from inhaled air. So in this question, I want you to know that some questions will limit your answer because, for example, in this question, other than changes in percentage composition, so you cannot just copy the table because some of it, okay, are the percentage composition. So for example, oxygen, carbon dioxide, nitrogen, and other gases, especially nitrogen and other gases, because the percentage they do not change, okay. So actually you have nothing to say, okay, for nitrogen and the other gases. But for water vapor, you can mention it, okay. So I give you some hints. Exhale air or inhale air, which one is more moist, okay. And for temperature, which one is warmer, okay, warmer, and which one contains a larger amount of dust or bacteria, okay. So it is the hints for you. So it is question 19. If you have any question, you can leave your question in the message box. I will answer you as soon as possible.